All right. Good afternoon, good morning, and good evening for everyone. My name is Jason Straight with the Pass Cloud Virtual Group. Today's presentation is Modern Azure Data Warehouse with David Almazan. I forgot to double check it. Sorry about that. Alzamendi. So that said, we'll get started here in just a moment, and I'll pass it off. And apologize for my frazzledness at the moment. I'm having some laptop issues. So let's get things going here with some announcements, and then I'll hand things over so my frazzledness won't take away from what David's got to talk about here today. So before we get started, I just want to point out that our presentation is brought to us today from our sponsor, Quest Spotlight Cloud. Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers, leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB. Spotlight combines the best of the cloud with Quest's engineering insights from years of building database performance management tools. If you do have a chance, please go out and check their tool out. It's a pretty nifty thing. And at this point, I'm going to hand things over to David Alzamendi for Modern Azure Data Warehouse. There you go, David. You are now the presenter.
Awesome. Thank you, Jason. So let's get started. Thank you for having me, Jason, and thank you for organizing all these events. Okay, it is quite awesome, actually. So if you think about the modern data warehouse, actually, a few years ago, so while the data warehouse methodology is still valid, the technology stack that we were using during the past 10 or 15 years is not going to cover our new business needs, okay? That's why we need something that is new, it is modern, and it's going to help us unlocking the value of the information that we're storing. Before we start, thank you to Quest for sponsoring this event. You know how hard it is to run the event, so it is awesome that Quest is helping us with that. A little bit about me. I work as data analytics and cloud consultant at Wordy IT. We're a Microsoft partner, and our headquarters are in Australia. Okay. Actually, right now I'm in the office. It is 7 a.m. in Brisbane, Australia. I've been involved in different events as a speaker, such as SQL Saturdays or the awesome Definity Conference or the Power BI World Tour. Okay, but this is my first webinar, so I'm quite excited. This slide is in all my presentations. Try to get involved. Okay, it is quite important as a community that we continue growing. Try to get involved with your local groups. And if you don't have time to attend any of the local meetups or local groups, try to get involved with the blogs or the virtual chapters. Because actually, I've been following the virtual chapters for 8 years already. Our agenda for today is we're going to review the foundations for the traditional data warehouse so we can understand the modern data warehouse architecture. Okay. Toward the end of the session, we're going to include Azure into the mix, and we're going to see how Azure is going to help us implementing the modern data warehouse framework. Okay. At the end of the session, we're going to have the Q&A. Okay, if you think about the traditional data warehouse, I'm pretty sure that most of you already know what a data warehouse is, but so everybody's in the same page, we're going to cover the foundations. What are the main benefits about having a data warehouse? So basically, think about the consolidation of multiple data sources into a single repository. Okay, think about bringing the information from the CRM, from different ERP systems, for files that business stakeholders are updating manually. We're going to import all that information into a single data repository, okay? That single data repository is going to be our source of truth, and it's going to help us and help the business stakeholders to make better business decisions so they can improve the performance of the company, okay? There are a few concepts about a traditional data warehouse architecture that we need to understand. The first one is the ETL process: extract, transform, and load information. Okay. When you extract the information from a ERP system, for example, or from the CRM system, we only have data, right? We don't understand quite well the schema or the information that we can gather from that data. So the idea is that we're going to extract information from the sources, we're going to transform it to fit it in our data warehouse data model. It doesn't matter if it's a Kimball, Data Vault, or Inmon, because it's going to allow us to query that information once that it is in the data warehouse. The second concept is schema on write. So every time that you load the information into your data warehouse, it doesn't matter if it's the staging area or the destination area, you're going to assign a name of the table, you're going to assign a specific number of columns, you're going to assign data types for those columns in the moment that you write the information into the data repository. This is from the back end of many relational databases, for example, SQL Server, that it is using a symmetric multiprocessor system. Okay, the best example for this one is think about your laptop. So your laptop may have 4 CPUs, but those 4 CPUs are going to be sharing the memory and the storage across all the CPUs. And basically all the analysis is based on historical information. Okay, we're trying to answer questions such as what did it happen, when did it happen, and how did it happen. Okay, so let's give an example of a traditional data warehouse architecture. On the left side, as you can see, we have our sources, ERP systems, CRMs, other sources, and we're going to ingest the information into our data warehouse. And for this on-premises example, we're going to use SQL Server Integration Services. Okay, we're going to load the information into a SQL Server database. That is, it is using a symmetric multiprocessor system. Just to give you an update, this is going to change with SQL Server 2019. That is going to come with big data capabilities, for example, Spark. Okay, and then it is not required, it is not mandatory, but we may have an OLAP system, we may have multidimensional or tabular models with analysis services. Okay, and we'll use SQL Server analysis services. From the data warehouse point of view, as I said before, it doesn't matter if we are using Kimball, Data Vault, or Inmon data modeling methodologies. Okay, and at the end of the pipeline, we're going to offer that information to the business stakeholders using reporting services or Power BI report server or any other reporting tool. Okay, cool. Let's continue. Now let's talk about the modern data warehouse. Okay, there are a few good reasons why we need a modern data warehouse architecture. A few examples to cover why we need a modern data warehouse are the population growth, the Internet of Things, and the smart cities. Okay, I'm going to share with you a web page that we have here. Okay. It is loading. Okay. Not a problem. So the idea is that if you think about the population growth, so right now there are 7 billion people in this world, okay? And it is incrementing by 1 billion people every between 10 and 15 years, okay? And you may think, okay, people, maybe the population growth is not that important as the number of devices per person, okay? If you think 15 years ago, the only smart device that I had at home was my laptop, okay? But right now, I have a Google Home, we have 3 laptops, we have the robot vacuum. So we have so many new devices that the volume of information is rapidly increasing, put it that way, okay? If the SQL Server was processing 10 gigabytes or 100 gigabytes of information a few years ago, now we need to look at technology that is able to process terabytes of information. I like to think that a modern data warehouse is to stay on top of the wave, okay? Try to use the latest technology, okay? Actually, if you think about the concept of modern data warehouse, what is modern right now is not going to be modern in a few years. So try to keep up to date with the technology. Try to build a framework that is able to change, to adapt, and to implement new technologies, okay? Because if you are not up to date, your competitors, okay, are going to take the lead. Some characteristics of a modern data warehouse, we need to call out the 3 V's, okay? Variety, any shape, any source. This framework is going to allow you to load semi-structured, non-structured, and structured information within the same framework, okay? Just to clarify, it is important to understand that there is not or I have a traditional data warehouse or I have a modern data warehouse, okay? You can have a combination of both, okay? And implement the technology as per your business needs, okay? The second one is the volume. As I said before, now we want to process terabytes of information in a few seconds. And SQL Server is great, okay? But SQL Server was built 40 years ago, okay? And there was not a requirement at that stage to load terabytes of information. Now we have a Spark, now we have Azure Data Warehouse, now we have any Hadoop system. That idea is to work with big volumes of information. And the last one is velocity. Everybody has experienced this challenge where the ETL process or the data movement pipeline takes hours and needs to load the information overnight, and it takes 6, 7 hours, 8 hours, 10 hours, okay? That's no longer the case. We have technology to make the information available for the business in less than an hour. We just need to use it, okay? Agile. I think that this is quite important, okay? There is not, imagine that a business stakeholder comes to you and asks for a report, and you tell the business user, no, that information is not available. It is not in the data warehouse. Or I will give you the report in 2 or 3 days, okay? That's a really bad scenario, okay? You want to offer your business stakeholders the information as soon as possible. You want to engage your business stakeholders, and with a modern data warehouse architecture, using agile methodologies, you want to deliver information in sprints or almost every day. The information is going to be available for the business users 24/7. And we're going to include as well advanced data analytics. Okay, if in the traditional data warehouse we were worried about what happened in the past, now we're going to try to predict what is going to happen in the future, as well as applying machine learning algorithms. I will include the data lake as well, okay? Think about a data repository for the enterprise where we store all the information in raw format, okay? It doesn't matter if we're talking about CSV files, JSON files, XML files, binary files. So we don't know the value of the information in the data lake, but we do know that all the information is there, and we're going to be able to build reporting on top of that information without going through the data warehouse pipeline. Some new concepts in a modern data warehouse architecture are the ELT process. Now we're going to extract, we're going to load, and after we load the information, we're going to transform it. And it's because all the new databases, backends, like Hadoop or Azure Data Warehouse, they are prepared to do bulk inserts and loads and apply the transformations after you load the information. Let's put it this way. If you follow the ELT process with Azure Data Warehouse, you're going to load the information faster. Think about polybase as well. A schema on read, we are not going to longer, maybe it is not required to assign a schema when we write the information. And the best example is a data lake, okay? If you have 5 CSV files and 5 JSON files into your data lake, you may want to use Azure Databricks to query that information, and you're going to assign the schema, the name of the columns, the name of your tables when you read the information. No, when you write the information into the data warehouse data repository. And now the architecture is going to change. We're going to be talking about the massively parallel processing system, which I'm going to explain in the next slide, I believe. Okay, just to make sure that everybody's on the same page, on the left side, we have the symmetric multiprocessor system. I think that the best example for that one was the laptop. So let's focus on the right side, and we're going to talk about the massively parallel processing system. Okay, so the idea is that we have a control node that is going to receive, just a sec. Okay, we're going to have a control node that is going to receive our queries. Okay, it's going to receive all the queries from the different users. This example applies to Azure Data Warehouse, but actually it applies to another big data systems as well. Okay, this control node is going to receive all the queries and is going to distribute the queries across different compute nodes. Okay, the big difference with this one is that each compute node has its own memory and its own storage. Okay, the CPUs are no longer sharing storage and memory at the same time. Okay, that means that if we have a really small table with 1,000 rows, okay, and somebody is querying the customer ID from the customer table, okay, the idea is that the control node is going to receive the query. We're going to bring that query here, and each control node is going to look after 250 rows. Okay, I hope it's clear. So remember that. That is why it's going to go faster. We're going to decouple storage from compute, but each compute node has its own memory and is going to be querying a specific number of partitions in the storage. Okay. Let's go with an architecture example. This is the architecture example from Microsoft. And the idea is that here, first of all, on the left side, you're going to see that we're going to start talking about unstructured information. And we have as well the structured information, okay? That is a CRM system, relational databases, or CSV file, any type of flat file, okay? We're going to use Azure Data Factory to load information in Azure Blob Storage, but as well to load information using Polybase in the Azure SQL Data Warehouse and trigger the refresh or the Azure Analysis Services model. Okay. So the idea, if we focus in the high pipeline, it is quite similar. If we focus in this pipeline from here, it is quite similar to the traditional data warehouse architecture. Okay. So when you're using Polybase, as per best practices, you want to extract, load, and then transform the information. And also we can start talking about the data lake. Okay. If we store all the structured, semi-structured information and binary files, everything here from our enterprise, we can start talking about the logical data lake. Okay. In the Azure Data Warehouse, it's going to be using the massively parallel processing system, not the symmetric multiprocessor system anymore. Okay, as an example. In the low pipeline, as you can see, we are including advanced data analytics with Azure Database. A really cool feature about this architecture is that you don't need to build everything the first day. You can build as you go. Okay, Azure Databricks, for example, you can include this as per your business needs. Imagine that you have a data scientist that they want to perform some analysis or deep analysis across all the enterprise information. So at that point of time, you are going to start Azure Databricks, and after they finish that data analysis, you can stop the service. So you're going to stop paying for it. You may have an Azure semantic model with tabular model. Just a quick reminder that multidimensional models are not available in Azure Analysis Services. And then you're going to offer the information in a single pane of glass, such as Power BI. Another good example here, if we look at the left side, we have the structured information. We have unstructured information here, but this is IoT information. And in this example, we are using Azure HD inside Kafka to stream that information to our Azure Databricks to apply machine learning models, as well to our Azure Data Lake to store the raw information. When you think about Azure HD inside Kafka, this is now supported by Azure Event Hubs. So you don't need to create the Azure HD inside service anymore. You can just use Azure Event Hubs. And the rest of the pipeline is the upper one. This pipeline from here is our traditional data warehouse architecture, but all what is in this line is part of the modern data warehouse architecture. I believe that next week or in a few days there is going to be a presentation about Lambda architecture. And if we split this architecture, you're going to see that the Lambda architecture has a speed layer where we are processing the real-time information, IoT information. As soon as possible, we apply machine learning models and we send back the information to our customers that are using the application. And we have the batch layer that is our traditional data warehouse data movement that runs overnight, but that with Azure Data Warehouse and using Polybase, it's only going to take a couple of hours or less. And we have the serving layer, that is where we offer the information to the customers. It could be analysis services, Power BI, or any other reporting tool or built-in application. And finally, let's talk about the cloud and how it's going to help us implementing the modern data warehouse architecture. Okay, when we talk about cloud, you can think about Google Cloud, Amazon Web Services, but we're going to be focused in the best one, that is Azure. Okay, and you want to go cloud because you're going to allow your IT department and any other business intelligence department to spend more time delivering value to the business stakeholders. Okay, think about. I remember a few years ago, people were concerned about, okay, maybe we don't need DBAs if we go with a cloud service. Actually, we continue. We need DBAs, we need sysadmins, but they are going to be more focused delivering value to the business. We're going to have cost-effective solutions because in Azure, you're going to be using pay-as-you-go subscriptions. That means that if you need a service for 2 hours, you're going to be allowed to use that service, start the service, deliver the solution, and stop the service, and you're going to be billed only for those 2 hours that you have used the service. Unlimited resources, up to a point, this depends on each Azure data center and region, but let's put it this way. If I need a Spark cluster in Azure Databricks with 200 gigabytes of memory, I can go right now and create a service and take advantage of it, right? I don't need to wait for anybody else to go and get the hardware, install the software, and make the service available for me. We can go and create the services and assign resources as needed. Another good example is if your ETL process or ELT process runs overnight, okay? If you need to load 2 terabytes of information, you may want to assign more resources just before starting the data movement so you can speed up the process. Okay, if I need to load 2 terabytes of information, maybe I assign more resources to the Azure Data Warehouse, more memory, more CPU, more Azure Data Warehouse units, so we load the information faster, and after we finish loading the information, we can return those resources to the data center. Okay, that means that during a period of time, we have more resources, and then we bring it back in the tier. Agile delivery, this is quite important. It's going to allow us to deliver solutions rapidly. Not only that, you know that when the product teams, they release features, the first place where they are going to release those features is in the cloud. It is in Azure. While with SQL Server on premises, you need to wait 1 year or a couple of years. You think about the latest version or public release version was SQL Server 2017, and now we have 2019. It is a 2-year gap. Okay. Mobility as well. It doesn't matter if your company has only, as a retail company example, that you may have 1 store right now or 2 stores in your city, but as you grow, you can make your data available in different regions and city just by going to the Azure portal. Now, if you are going to migrate to the cloud, keep calm and don't rush. Okay, just find the best moment to move your services to the cloud. Going to the cloud, it is great. I love it. Okay, it is not if it's going to happen, it's when it's going to happen. But you are going to be able to choose the right moment to migrate to the cloud. And as per suggestion, I suggest to migrate your services incrementally. Start with 1 service, and then after you finish migrating that service, it could be your front end of your web portal. You can continue with different services. Don't see the migration to Azure as a let's move everything, because that's going to be quite challenging and risky. It is important when you're talking about the cloud to understand the different cloud models. If you look on the left side, and we talk about on-premises, this is not a cloud model actually, but if you want to compare the on-premises, is where you need to look after everything. Okay, if you need a SQL Server, so you need hardware, you need people who set up the storage, the virtualization for the OS, somebody who installs SQL Server, and they need to make the product available for you. When you start with the cloud models, there are not only 3, there are many of them. These are the key ones for me. Infrastructure as a service. So let Microsoft manage your virtualization, servers, storage, and networking. And a really good example for infrastructure as a service is VMs, right? Azure VMs. Within the platform as a service model, now Microsoft is going to manage pretty much everything. You only need to look after the application and the data. And the largest offering of services comes with this flavor as a platform as a service. Think about Azure Data Warehouse, Azure SQL DB, Azure Data Factory, Azure Analysis Services. There are many examples that we're going to look in the next slide. And finally, software as a service. A few examples are Power BI, Office 365, SharePoint Online. Let's go and have a look at different products that are available for us and we can use in our data warehouse solution. Important to understand as well, Azure has 54 regions. That doesn't mean that all the services are available in all the regions. Just before you start any cloud development in Azure, make sure that you choose the right region and it has all the services that are covering your business needs. Eventually, all the services are going to be available in all the regions, but this release happens incremental. Another good point actually is that once that you are in Azure, you're going to be able to use any of their services, not only the data warehouse services that we're going to review. Azure is offering more than 1,000 services between products and the different options for the tiers. This is my cloud tool set, and these are tools that I use for my data warehouse solutions in Azure. For storage, we can think about Azure Data Warehouse, SQL DB, Cosmos DB for offering the information to the clients or applications, and the storage blob to create a data lake or just to store files or archive files. For hosting services, we have the VMs. Serverless compute, we can talk about Azure Functions. For advanced data analytics, we have Databricks. Databricks has a huge number of options. You can create logical data warehouse within Azure Databricks. You can do pretty much everything with Azure Databricks if you want to in the data analytics space. From version control and documentation, so the one that I like a lot here is Azure DevOps. And because it is really easy to get started. If you don't have version control right now, Azure DevOps is the way to go. You can start having version control today. And not only that, you can think about a continuous delivery and continuous integration. For connectivity, Express Route or on-premises data gateway, the main difference when you talk about the Express Route, you need to think about Microsoft is going to give you a VIP channel for your network bandwidth, while the on-premise data gateway is going to establish the connection between your on-premises environment and Azure, but it's going to be using the public bandwidth. For data integration, we have Azure Data Factory, and it is great to see how Azure Data Factory is getting more adoption since the release of version 2. It really easy to start with Azure Data Factory right now. You just need to go to the web portal, forget about creating the pipelines with PowerShell and JSON files. Just to get started, go to Azure Data Factory. They have a really good front end where you can start building your ETL process. For IoT, maybe more related to data analytics space, is going to be Event Hubs. It's a one-channel communication service ingestion. That means that we are going to extract information or ingest information from our devices into our Azure Data Warehouse. And IoT Hub, the other service here, this is going to give you more features. As an example, you are going to have the two-channel communication. Not only you are going to extract information from your device, you are going to be able to talk and give orders, command orders to your device. As for example, if you need to update devices, this service, IoT Hub, is going to allow you to do that. For event processing, we're going to talk about the stream analytics. For semantic model, reporting and delivery, we have analysis services and Power BI services. Then we have cognitive services that is going to allow your data scientists, developers to deliver more models and spend less time building them, okay? Because think about artificial intelligence as a services. That's a really good definition for cognitive services. If you want to group them in the different cloud models, you can see that in the VMs, it's a really good example for infrastructure as a service, as well as you have a HD inside with Kafka. But when you talk about platform as a service, the offering is the largest one, okay? And within software as a service, with examples, as I said before, Power BI service, Azure DevOps, GitHub Code, or Office 365. Artificial intelligence as a service, cognitive services. Okay, I think that pretty much that's all. So before we start with the Q&A, my suggestion is don't move everything to a modern data warehouse architecture, but go and explore the different services that are going to bring more value to your existing data warehouse solution. Now, if you don't have any data warehouse solution at this stage, I do suggest to go directly with Azure and using the modern data warehouse architecture that I showed before, and it is available in azure.com. So that's all. Jason, are you around there?
Yep, I am here. Yeah, sorry about that. I had to get my mute unclicked there. And so for everyone that's in our presentation here today, if you have any questions for David regarding what he's been talking about today, now is an ideal time to put those questions in. The question that we do have so far is basically folks were asking about your PowerPoint, and I can't recall, but I think you might have actually already sent that over to me. Did you catch that, David?
About the PowerPoint slides?
Yeah.
Yeah, not a problem. I'll send them to you, and you can make them available for them.
Right, I can put them up onto the meeting archive. And see if there are any questions. Give people a moment here. It looks like there are not any questions. So I want to thank you, David, for presenting today. This is really great and informative. Really kind of knocked out all the different areas where people can be looking at building out their new, lifting up their data warehouse. And we did get one comment that it was a very clear explanation, and I thank you for that compliment for David. And so folks, thank you for attending here today. Thank you, David, for making time in your morning. It's always nice to be able to get presenters from other parts of the world and not to have all of them fairly local to myself here. And everyone that attended today, thank you very much, and talk to everyone hopefully on Thursday. Thank you, David.
Awesome. See you then. Thank you, Jason.